Hey everyone, and welcome back. In our last explainer, we covered the basics of machine learning. Today, we're going to go one step deeper and talk about one of its most powerful and, honestly, most fascinating subfields, deep learning.
So, to kick things off, let's think about something you probably do multiple times a day. How in the world does your phone know it's you and unlock just by seeing your face? Or how does your voice assistant actually understand what you're asking it to do?
Well, it might feel like magic, but it's not. The secret behind all of these incredible features is a really powerful type of artificial intelligence called deep learning.
So you might be wondering, where did an idea this big come from? Well, the inspiration is actually something we all have, the human brain. We're going to take a look at how deep learning is basically trying to copy the way we think.
So at its heart, here's the definition. Deep learning is a specific kind of machine learning. It uses these things called neural networks, which are designed to work a lot like our own brains to learn from huge, and I mean huge amounts of data.
And this is where it gets really cool. Think about it. Our brains have billions of neurons, all connected, helping us see, learn, and remember. Deep learning tries to recreate that digitally. It uses what we call artificial neurons and connects them together to form a network. It's really just learning from the best computer out there, our own brain.
Okay, so that brings us to a really important part of the name itself. We're about to explore the power of layers, which will finally answer the big question: what actually makes deep learning deep?
Let's just get right to it. With all this talk about brains and networks, why do we call it deep learning? What's so deep about it?
The answer is actually pretty simple. It's called deep because the learning process happens across lots and lots of layers, stacked one on top of another. It's not one single step, but a deep stack of them.
And this visualizes it perfectly. Imagine you feed it an image. The first few layers, the lower ones, learn really simple stuff like detecting basic edges or shapes or colors. Then, that information gets passed up to the middle layers, which start to piece those simple things together into patterns, like an eye or a nose. And finally, the highest layers take all those patterns and figure out the overall meaning. Hey, that's a face. This process of going from simple details to complex ideas, layer by layer, is the absolute key to how deep learning works.
All right, so now we know what it is and why it's deep. Let's look at the different types. And the best way to think about this is to picture a toolbox. You wouldn't use a hammer to turn a screw, right? In deep learning, you always need the right tool for the right job.
First up in our toolbox is the original, the classic, the Artificial Neural Network, or ANN. You can think of this as the foundational model, the one that started it all. It's perfect for more straightforward prediction and classification jobs.
So you'd use an ANN for things like predicting a student's grades, or maybe running a simple recommendation engine. It's that foundational tool that many of the other, more complex models are built on top of.
Now, let's grab our next tool. For anything that involves sights, so images and videos, we need a specialist. That's the Convolutional Neural Network, or CNN. Simply put, CNNs are the models that give computers the ability to see and understand the visual world.
This is the tech behind your phone's Face Unlock. It's also what helps doctors analyze medical scans like X-rays, and it's what allows a self-driving car to detect things like pedestrians and other cars on the road.
But what about data where the order of things really matters? You know, like words in a sentence, or the price of a stock over time. For that, we need a recurrent neural network, or RNN. Its special power is memory. It can remember what came before in a sequence to help it understand what's happening right now.
This memory is exactly why RNNs are perfect for things like speech recognition. You have to know the previous word to understand the next one. They're also great for analyzing any data that unfolds over time and for other basic language tasks.
Okay, but what if you need a really good memory? Sometimes RNNs can struggle with long sentences or sequences. That's where their advanced cousin comes in, the Long Short-Term Memory Network, or LSTM. Think of it as an upgraded RNN that's specifically designed to remember information for much longer.
This long-term memory is why LSTMs are fantastic for more complex stuff, like the autocomplete or text prediction on your phone, sophisticated chatbots, and even real-time language translation services.
And that brings us to the cutting edge, the powerhouse tool in our box, the Transformer. These modern models are incredible. Their superpower isn't just remembering things in order, but understanding the context of the entire sequence at once. They are the engine behind the whole generative AI revolution that's happening right now.
So whenever you're using an advanced chatbot or a really smart AI assistant, you are almost certainly interacting with a transformer model. They are what allow these systems to understand all the subtle meanings and nuances of how we talk.
So, if you take just one thing away from this whole toolbox section, let it be this. There is no single best model. The key is understanding that different deep learning models are specialized tools, each designed to solve a different kind of problem.
We've covered the what, the why, and the how. So now for the most important part. Let's bring this all back home and see how this amazing technology is already shaping your world every single day.
I mean, from the face recognition that unlocks your phone, to the voice assistant that plays your music, from the self-driving cars on the horizon, to the AI helping doctors make diagnoses right now, all the way to instant language translation and the chatbots you talk to online, deep learning is the invisible thread connecting so much of our modern technology.
We've seen how deep learning can understand and recognize patterns, but that leads to one last, really fascinating question. What happens when these powerful models go beyond just recognizing things and start to create brand new text, images, and ideas all on their own? Well, that is the world of generative AI, and it's exactly what we'll be exploring in our next explainer. I'll see you then.